Today I will be showing you how to divide polynomials using long division. This method is fairly simple, and I will explain exactly how this can be done. First, to get some terminology out of the way, f of x will be representing the polynomial that you're dividing. D of x, which is your divisor, will be representing essentially what's going to be dividing your f of x, so your polynomial. In this case, obviously x squared plus 5x plus 7 is going to be our f of x, and x plus 2 is going to be our d of x. Using long division to do this is extremely similar to doing it with numbers. So before I jump in and show you, I'm going to do a quick example with numbers. So this 257 is kind of like your f of x, although it obviously is not your f of x. It is not a polynomial, but in this case it's just good to think of it as one. Your 5 would be like your d of x. It's what's dividing the 257. Now for the example. So first, we start by drawing the 5 outside your bracket with the 257 inside. So now the first thing you want to do is see how many times 5, your divisor, would go into the first number. So the first number to the first number. In this case, 0. So you move on to the second number inside the bracket, and it turns into a 25 now. How many times does 5 go into 25? 5, of course. So we put that 5 up top, and multiply what's outside by what's on top, and bring it down below. And now we subtract these numbers. Obviously 25 minus 25, that gives you 0. But you proceed to now bringing down the 7. See how many times 5 goes into 7. Obviously once. So you put the 1 up top, and do the same thing as you did before. You multiply the 5 by the 1, leaving you with 5, and you subtract again, leaving you with a 2 on the bottom. So this 2 essentially represents your remainder. So what we can gather from this is that 257 divided by 5 would give you 51 with a remainder of 2. Now, for the point of this video, back to our two polynomials that we had. So the first one, x squared plus 5x plus 7, and of course our divisor, x plus 2. So setting this up would be similar to what you did with the numbers in the last example that I showed you, with the divisor on the outside and the polynomial on the inside. So what you want to do first is you want to take the variable with the highest degree, so the highest exponent, and you want to see what you would have to multiply that by to get the highest exponent in the polynomial. So in this case, x would have to be multiplied by x to get to x squared. So that x goes on top. And you multiply the whole divisor by that x and put it below. So x times x, x squared below, and 2 times x, 2x below. Now, similar to what you did before, subtracting the 25 by the 25 and stuff like that in the last question, you subtract. Only same degree by same degree, so same exponent by the same exponent. The x squareds cancel out, and the 5x, you subtract the 2x off it, leaving you 3x. And almost exactly the same as before, you probably think that, yeah, you would bring down the 7 and put an addition sign in between. Now, you take that biggest exponent variable in the divisor, and you see what you'd have to multiply that by to get the largest degree variable in the polynomial that you have below. So in this case, it would be 3. X times 3 is 3x. And now you multiply the whole divisor by that again. So x times 3 is 3x. 2 times 3 is 6. Addition sign with the 6. And you subtract once again. So 3x minus 3x, that would be giving you 0, of course. And then the 7 minus the 6, that would leave you with 1. And we know that that 1 represents our remainder. So what does this actually mean? This means that x squared plus 5x plus 7 divided by x plus 2 gives you the number on top, so the x plus 3, 3, only there's a remainder of 1. So that's it. That's how you divide polynomials. So you can take it from this guy. Math does rule. And if you really want to believe him, you can check out our next videos, which are going to be on applying this method, and you're even going to be learning more efficient routes to finding the remainder. So see you next time.